There should be music. Oh, well, unfortunately there is no music around here. Oh my God. Hello. Sorry. So, my name is Didier. I will take pictures of you, and maybe now in front of this nice sky, a picture of me. Okay, and I will try to put it on the screen. I don't know. Oh yeah, nice. Did you see my nice shoes and my nice glass? But now we will try to print that one. Red shoes, green drink, and blue sky. Let's try to print it out. Oh my God. What's going on? Cyan. I can't understand that. Maybe we try another way. What's going on? Magenta. Can you explain that? I can't understand. And then a third attempt, maybe. Oh, I hope it will work, because it's like nightmare. It's yellow. So I don't really understand what's going on. So maybe we need a specialist around here. Why cyan, magenta, and yellow? I think it requires a little bit of science. You know, this is a story with 3 actors. You first have the light, for instance, the light of the sun. Then you've got an object, a color, which is made of molecules. And the molecules will interact with the light of the sun. And then you will have the third actor, your eyes. And your eyes are very important because they perceive the interaction between the light and the object to their knowledge. So let's try to see how we can explain that. Oh. I'm sorry, but it doesn't switch to the next slide, so I cannot go further now. I'm sorry, I can't go further. Yep. Oh yeah, great, it works. Thank you. So there have been big scientists like me and Newton, for instance, who've been working on light. Newton realized that the light of sun can be decomposed into 7 colors. The colors which are written right here on the next slide. Oh my God, there's a bug with the slide manager here. I cannot go to the switch to the next one. Maybe next slide from the computer managers there. I'm sorry, I cannot go further. You should see the decomposition of light into its... Oh, thank you. So, there are 7 colors in the light of the sun. That's what Newton realized. But there are other scientists like Goethe, something like 1 century later, who were quite opposed to Newton's theory. And Goethe said that the colors are a matter of perception. But what does it mean, perception? Perception means that we have to look deep into our eye. You know, we go deep into our eye where the retina is present. What is the retina? The retina, this is what is on the bottom of your eye, on the top, on the end of your eye, and the retina is made of rods, but also of cones, and those cones are sensitive to only 3 colors: red, green, and blue. So how can it come that red, green, and blue cones can feel all the colors of a rainbow, for instance? Let's take a nice rainbow, and let's take the extremities of this rainbow and try to bend it This is what we call the circle of complementary colors. You can see red, green, blue, but also cyan, magenta, and yellow. This is what the white light of the sun looks like on this circle. Let's try to understand what happens when you have an object of a certain color, like an ink cartridge. Eventually, I will try to see, oh, but there are ink cartridges in my printer. Cyan, magenta, and yellow. So now I do understand why I had these cyan, magenta, and yellow printings. So let's take a cyan ink. Cyan ink is perceived this way because the light of the sun, which is absorbed mostly, is the one opposite to the object, to the painting, to the color. This is the same for magenta. Magenta, as you see, looks like magenta, is perceived magenta, because the colors opposite to magenta are absorbed, and so on for yellow. So now, what happens if you mix the colors of your printer, inkjet printer, or the colors of your painting? Let's try to mix, for instance, cyan and magenta. As each of these two colors absorbs a certain quantity of light, when you mix them, the result is nothing but blue. So you can create blue by simply mixing cyan and magenta. What happens when you mix cyan and yellow? The same process happens too, and when you mix cyan and yellow, you can produce green. Oh yeah, okay, I start to understand. And now, of course, when you mix magenta and yellow, you will obtain red. This is perfect. So, to summarize, you can obtain the different colors of the rainbow by simply mixing three colors: cyan, magenta, and yellow. And so, if I try to repair my printer, maybe finally it will produce red, green, and blue. Oof, perfect, that's repaired. So now, let's try to understand what happens if we mix all colors together. My God, 3 minutes remaining. All colors together, that will produce, of course, black, because each of these colors absorbs a certain quantity of light. We will try to understand how our eye perceives the different colors which are present on a disc. It can be either the cyan, magenta, red, or Newton disk, which is present here. When you spin it at very large speed, you thought you would observe some black. This is not the case, simply because our eye is not fast enough to see the individual colors which would be mixed. They are not mixed together. They are each individual. So what happens now with this one? Light. What about light? So we will try. Oh my God, I had something. This is not important. I can use this one. We will directly switch to the other computer. If I can show you here what would have happened on a white thing like this one, you have red, green, and blue. And when you mix them, if you mix red and green, you obtain yellow. Then if you mix blue and green, you obtain cyan. And then if finally you mix blue and red, you're supposed to obtain, oh yeah, you're supposed to obtain magenta. It will become much clearer if we check that with a spectrometer. The spectrometer is a special device that can help you determine the spectrum of a light, like this one, for instance. This one is white light. It's made of 3 individual LEDs. And then, if we try to make it change the intensity of each of the individual LEDs, it starts. You see that by mixing red and blue, you obtain magenta. Nice color. Then, when you will have less blue, you will have the pure red. And when you add some green to it, you obtain first orange, which becomes more and more yellow, as you can see here. And so on, so on, so on. You can change all the colors. So we have understood yet, by simply coming back to our previous discussion, that we can mix the colors, we can mix the lights, and the colors can be mixed as subtractive colors. You remove light from the sun. While you mix lights, you sum the lights. You add the lights to each other. So let's go to the next slide to finish. And I have in between my pointer, well, light, this is the additive system, as we said. With red, green, blue, you can obtain cyan, magenta, and yellow. And I will not show you the last experiment, which was with balloon and with a very dangerous laser. But if you want to have information on that one, I can show it to you afterwards, because I've exceeded the time which was allotted to me, including maybe the pointer problems. I don't hope. Thank you very much. I hope you understood a little bit about colors. My pleasure. I hope you will applaud a lot. Thank you very much.
Genau. Hebt euren Applaus auf.